since you have a question, might as well put it on the board, right? And have access to everything else. So let me just do that, if you don't mind. Just 1 second, please. Where are you? Bada beam, bada boom, bada beam. No, that's not it. It's this one. Boom. Okay. All right. That's not it either. So it's under content, under test. No, under not. Yes, it has to be not there. That's to create something. So oh yeah, here it is. Sorry. Okay. All right. So all right. So let's share the screen. Obviously, some questions are very simple, so it doesn't really matter, right? But in this case, the up arrow key is used to scroll back through the commands, right? The up arrow. Down arrow, you go down, but down, that means when you're already up and you want to go back down. But up arrow is to go back through the commands. Now, this one here, obviously, 2 to the power 4 has to be evaluated first, because power is ahead of all the other operations except the parentheses, of course. So that means 2 to the power 16. And then, because division and multiplication have equal priority, then 16 divided by 2, that's 8. And 8 times 2, that's 16. 16 plus 8, that's 24. So the answer should have been 24, right? So that's why I said, you know, maybe before what I had is that maybe I had 2 times 2 in between parentheses, right? So in this case, 16 divided by 4. So no, not even in that case. What did I have? Something else. I don't know why 16 was an answer. Unless I just selected the wrong answer, right? Because that would have been, you know, 16 divided by 4, that's 4 plus 8, that's 12, right? So maybe I had a different version, right? Maybe I have a different version that leads to 16. And to lead to 16, oh, yes, maybe I had the 4 halves in between parentheses, because then it comes 2 to the power 2, which is 4. 4 times 2, that's 8. 8 plus 8 is 16. So as I said, sometimes I change the version, but I forget to change the answer. That happens, right? But that means I have to look into it. So the answer should have been, in this case, 24. Obviously, people at 24 should get a credit. And the other people, because that's my mistake, maybe I should give credit to everybody. So at least for that question. So if you had already, yeah, I know. That's why 24 should have been the correct answer. So I'm going to fix it later, right? That means everybody gets a point there. Yes, of course. Command clear, that's to remove all variables from memory. Infinite minus infinite, that's not a number, because that's not something deterministic. You do not know what the value is. Arctangent, that returns the angle in radians, because there is no d. All right. The array 2419 is this one, because 19 is not involved, right? Obviously, I didn't have 19 anywhere, right? So, but still, I mean, that's 2 plus 4, that's 6, plus 4, that's 10, plus 4, that's 14, plus 4, that's 18, which means this one here. Plot y comma x, that's x versus y. So y is the horizontal axis, because the first variable is the horizontal axis, and the second variable is the ordinate, right, the vertical axis. And the reason I ask these questions is because a lot of times when students do a plotting, they forget, and instead of writing it as plot x comma y, they write it y comma x, and then what they have the graph, which is 90 degrees rotated, right? And so that's not acceptable. So that hopefully then they would remember that the first variable is related to the horizontal axis, and the second variable will be related to the vertical axis. Now, second problem is not acceptable, is not a valid name for a script file, because it starts with a digit instead of A to Z. It has to start with A to Z. You can use MATLAB to solve most mathematical problems. Of course, that's true. Sometimes, you know, if you don't have the skills, or there's no function that can help you solve a problem, yes, that's possible, right? Now, the coefficients of the polynomial, we have a 4th degree polynomial, so it has to be 5 coefficients, right? So already, without even looking at the coefficients here, it should have been 5, right? 5 coefficients. And of course, there is the coefficient of x squared that is missing. It should have been a 0. That's why it's false, right? MATLAB is case sensitive. That is true. MATLAB for log of x stands for, this is the MATLAB function, right? It stands for the natural log of x. So this is in MATLAB, log of x. That means the natural log from a mathematical point of view, not log base 10. Right? When enter A is pressed after this one, it should be undefined function, because I want people to remember. They should pay attention to the typos. There is no T here, and so the MATLAB does not understand this function. Obviously, most times, people think, yeah, it makes sense, it should be 2, because when they read, they don't read the T and they ignore it, right? And so in many cases, I've seen that the problems that students have, or anybody I would have, is when we read something, we read in our mind, but not what is written. We read what is the correct version, and we say, there's no problem, right? Or you make a typo and you don't pay attention because to you it looks like the right function or right whatever. So to pay attention, right? Because a lot of times, when people use, let's say, they try to find the file name or a variable, and they forget that they use the capital letter instead of small case, and then of course they can't find it. So one has to be careful that if you want to use capital letters, you have to pay attention to be consistent, because they use capital A equals something, and then in an expression they use small a. Then they wonder why MATLAB says there's a problem with the program. Now the 4/5. This would be incorrect, even though 5/4 should be 1.25, but it's false only because when MATLAB answers, you see here MATLAB will display, so it should be 1.2500, right? That would be the correct answer. So obviously 1.25 is not a correct answer. That's not going to be displayed, right? Any question then after this?
Yeah, I have a question, Professor.
Sure.
Why would it be 1.2500?
Because that's how MATLAB, remember the default, which is format short? It always displays 4 digits after the decimal point, remember? Yeah. So here, the question, look at the question, will display, not will be equal to. If I said will be equal to, 1.25 is correct, of course, because it's 5 divided by 4.
Yeah.
Now you have to pay attention to the words, right? Will display. That means, if I execute through MATLAB, is that what I will see? No, it's 1.2500.
Okay, thank you.
You're welcome. And remember, that's what sometimes we use tests not only to get what you know, but also to teach you other things, to make sure you remember them, right? Sometimes it's details and sometimes it's important. But definitely you will never forget when you make a mistake. Anybody else? No? Okay. So let me then, instead of this, I want to deal with the projects. So, because by now you have enough knowledge to make many of them happen, right? So that means you can already start working on them. You don't have to wait until the semester, which would be a disaster, because at that time you have second exams, you have the final, you have projects, you have 10,000 other classes, so you don't want to do that, right? You always want to deal with things at the appropriate time, whenever you can, right? Get them out of the way so that you have more time for other things which are probably more complicated, right? Or when the schedule becomes heavy. So the first one here is you are asked to go to Google, right, and look for some graphics, any plot, simple graph, stairs, bars, pie chart, whatever, right? Now this is something you may not be able to do right away, unless it's a simple curve. A simple curve, that means like functions, curves like solid curves or something like that, right? Not bar graph, not pie chart, because we haven't learned that yet, right? That's in topic 5, right? But at least you can start, right? You can start in the sense that once you have access to that graph, make a copy of it, paste it in your document. Show us what the true graph or what the original graph looks like, right? Then try to use MATLAB to reproduce it. For example, if it's a bar graph, you just take a look at the values and then try to duplicate them in your own bar graph display. If it's a simple curve, take as many points as you can and then introduce them as an array and then plot them. You may not have as many points as the original graph, but if you have enough points that you can take from the curve, that means for every x, which is y, for every x, another y, for x, another y, then if you have enough points, you can just say x equal between brackets, all the x's, then y equal between brackets, then plot x, y. That's it. Very simple. Of course, you're supposed to use things that we have already seen, like the title, the x label, y label, but to make it more interesting, then they say you should write at least 2 paragraphs, right? The first paragraph So now we're not just talking about MATLAB calculations like you do in homework. Now you have to type things. The first one is describing the graph. You don't give your interpretation. You just describe what the graph is about. It's about the number of cars that has been, exported by Toyota during the year, just before the COVID-19 crisis at the very bottom, right? Then the second paragraph would be your interpretation. You say, we see that the number of cars that have been exported during the crisis had gone down, and we assume that it's due to the fact that the factories had limited amount of employees. But that means now you give your own interpretation of that behavior of the data, or whether it's about population in Polynesia or whatever it is, right? So the first one you just describe, no interpretation, not your point of view. The second one is your point of view, your observations, your comments. Agreed? Anybody has questions about that one? No? So let's go to the second one. So remember, yeah, it does, right? Especially now you're in charge. See, this is what I like about the projects. Right? You're in charge. You're the one who decides the topic. You're the one who decides what to write. That means you're in charge. And that means you take credit when it's a good job, and you have to abide by the consequences if it's not an excellent job. But the point here is that that's what we learn, right? Nobody says that in life everything has to be beautiful. But if you don't take charge, then you will always be somebody behind everybody else. Right? Your contribution will be disrespected, ignored, and you cannot make things happen. So yes. So okay. All right. So this is the first one, and remember there are 7 parts to it. And every part is to be submitted, right? So don't think that, because a lot of times, students that ask me, like, are we supposed to do 1 part out of 7? No, you do all of them. And here, even though it says, well, in this case, it doesn't say, right? But sometimes in some of them, it says team project or individual project. As far as I'm concerned, everything you submit is team-oriented and team-based. So there's going to be 1 report per team. Agreed? So I don't have to repeat that, right? 1 report per team. There will be no individual project parts. It doesn't matter what it says here, right? What it says here, it will be one report per team. No individual submissions, right? Because I want you to learn how to interact, how, especially when you're going to be going for industry and you're going to work with other people, you should learn here how to get people to be motivated, even though you can say, that's not my responsibility. Yes, it is, right? Because if they misbehave, then the whole team will go down, right? So you have to teach them. You have to learn from them. You have to be responsible for assisting them, right? And being assisted, and so on and so forth, right? So the point here, you have to learn before you get to industry, where then you make a mistake, you get fired, right? So learn to lead and to follow at the same time. Okay, so again, this is one. The second, now this here involves an audio file, right? An audio file. You can see that there is here an MP3 file that you would listen to. Now, what is that story, right? The story here is about astronauts and the fact that they tend to lose bone mass in space much faster than on Earth. In fact, if you listen to the audio file, it talks about 1 to 2% bone mass loss every month. But this is a disaster for a human being, because if your bone mass gets to degrade, then that means you can break your bones much more easily. And that means human beings are not supposed to stay in space very long. Unless, of course, they come up with a solution in the future. But that story in that audio file, they will talk about consequences. They will talk about the origin of the bone mass. They talk about a lot of different things. And you're supposed to listen to it and try to write, instead of 3, just write 2 paragraphs about what you understand about the problem and your own conclusion, right? Your own interpretation. And so in this case, I hope for your sake that you don't copy and paste from somewhere on the internet, or try to copy what you hear exactly the way it's said, unless you put it in between quotation, because they will fire you for plagiarism, right? Oh, yes, it's already in content. It should be. I think it's called MATLAB project or something. I hope. Right now I'm saying things. Yeah, NASA project, right? It's a zipped file, so if you don't have a zip program, I will advise you to download a program called 7-zip, right? 7-zip, right? 7-zip, right? And this is free, and it not only unzips files, but it also zips files if you ever need to zip file, and it deals with almost every possible format of zipped file, right? There are so many different formats that exist. And the zipped version is supposed to be a way not only to combine different files together, but to make them require less space in storage. Sometimes, less space could be 30% less. Sometimes it's only 1 or 2 or 3%. But the good thing is that at least I can combine them into a single file when I want to post them or something. It makes it a lot easier. As you may have too many files to be posted, and that would take too much space, and then if you have 100 files to look at, you don't know how to locate the appropriate file, right? So by combining some of them, it makes it easier to manage. So again, remember, first when you listen to it, you write these 2 paragraphs that need to be addressing the discussion in that audio file. After that, now you have a graph here that describes how the bone mass gets to be increasing or decreasing in the life of men and women, right? So in the case of men, it increases more or less rapidly when they're young, or at least 30 years and younger, right? Then it stabilizes around 40 to 50 years old. Then it starts declining, right? It starts declining, not very sharply, but starts declining. And that's why when you get very old, your body becomes more fragile, or at least your bones, right? That's why you break them easily, right? However, in the context of women, you have that kind of increase, right? Improvement at the early age, up to, let's say, 30 years old. After that, it stabilizes, but when they reach menopause, they have a major decline, and that's why they have to be careful. They have to take additional calcium or whatever to try to compensate for it. And then it degrades again smoothly like men, right? But there is this sharp decline here that occurs, and then it becomes again normal. So that's why they go to lower level faster, at least around the age of 50 to 65, right? So that's when they have to be careful, because that sharp decline always leads to when you have an attitude in the way you behave, and then you forget that you had this major degradation in bone mass. So you have to start getting careful instead of waiting until you're 70 and you say, okay, now I have to be careful. It has to start earlier, right? But such is life, right? The point here is that why, when you have these decreases, which are not 1 to 2% per month, right? They're definitely much slower than that. So that means space is a big problem. And the only difference between space and the Earth is that the gravity is much smaller, right? And so that means the lack of gravity happens to be having a negative effect on the bone mass. So, in a sense that when you look at kids, right? In the old days, we always say to the kids, stop jumping, stop doing this. Of course, if it leads to the neighbor being upset, that's a problem, right? But the jumping, when it's done without, bothering the neighbor, is exactly what allows the bone mass to grow. Why? Because as you jump, right? As you jump, or due to gravity, the bones compress, and then when you stop the jumping, the bones go back to their, not only the original form, but they get to increase. It's kind of like the muscles. Every time you work out or you carry things that are heavy, you have these micro tears in the muscle, in the flesh, right? But then when you sleep, it fixes itself. But the fixing of the bones here adds up mass, adds more mass. So in a sense that the persons who are athletic at a young age get to have more bone mass than the people that don't, right? More solid bones. And so the idea here is that how to set up some gravity in space to allow for the same behavior, so that they can avoid the 1 to 2% loss every month, in which case they cannot stay long enough. If they stay more than 1 year, that's going to be a crisis already, right? And more than that, it'll be a disaster, right? Except if you start with a very heavy bone mass, or maybe they devise some things, some exercises, some gravity manipulation, or some pills, additional vitamins they take. I don't know what regimen these astronauts go for, but definitely it's a problem we have to pay attention to. So now the questions from this graph. Right. Of course, in this graph, you don't have specific points, so you have to estimate things, right? I mean, like when you look at this, you say it's approximately 1200, right, at this level, right? Approximately. Of course, you can be more accurate by using a ruler, using a horizontal line, using a division between 1000 and 1500 to find out where that point is, right? Kind of a grid. But again, estimations are acceptable, right? Are acceptable as long as it's not dead. I mean, if you say that this is 1300 at this point, then I say, okay, are you sure you're looking at the same graph, right? So you have to be careful that your estimates are estimates, but they cannot be too far off. So the first question here, it says from the graph of what is the average rate of bone loss between age 40 and age 70 for men and women? So if you remember, if I tell you the story, for example, that I drive from Newark to Philadelphia, and let's say, I'm not saying it's correct, but let's say I drive and it's 60 miles distance, and I drive and it takes me 1 hour. 60 miles, 1 hour, 60 divided by 1, that's 60 miles per hour average speed. It does not mean that in between I did not go faster or slower. But when you look at the average, you only care about the endpoints in this case, right? When did I start? When did I finish? And how much is the distance? And distance divided by the time, the duration, that's your average speed. So the same thing here. If I'm looking for the average loss of bone mass, I only care about 40. The point is here, which is approximately 1500, let's say. Then I care about 70, right? Because they say 70, right? So 70, then you try to estimate this one. I'm not going to give you the number in this case. That means you have to figure out how to estimate that number, right? And then you do this minus this divided by 70 minus 40. And that's the number of grams per year that a man or a woman would lose. Same thing here. It doesn't matter if there is a jump here that is extremely sharp. You just look at 40, you look at 70, and you do the difference divided by the years, which is 30 in this case, the range, and that's your loss. But then I just want to make sure also that don't tell me that this minus this over 30 is your loss, because if you do this minus this, that's a negative number. So either you say 5 grams per year loss, or you can say gain of minus 5 grams per year, but you cannot say a loss of minus 5, right? So you have to be careful about the standards on how we define a loss or a gain, right? So a negative gain is a loss. So if you gained negative $1,000, that means you lost $1,000. So when you talk about a negative number, which is a loss, then you say you lost $1,000, not minus 1,000, right? So the same thing here. When you look at the average rate of degradation of bone mass, make sure that if you use a negative number, you say that's the gain. If you use the magnitude, then you say it's a loss, because it's a negative number, that means it's a loss. Any questions so far as the first question is? So that for men and women. And by the way, I forgot to mention that every one of them requires a MATLAB script file. I don't care how easy it is, how simple it is. It's not about calculator. It's about using MATLAB to answer these questions. So I want sentences, I want units, and I want MATLAB script, right, showing how you obtain those numbers. Now, the second question, it says, suppose a 40-year-old male astronaut spent 6 months. So a 40-year-old man, he started already with 1,500 grams, right, of bone mass. And then he spends only six months, not 30 years, 6 months only. And of course, the question is, if he started out with 1,500, so they're already telling you 1,500, so, but I could have guessed it from the graph, right? It says how much calcium would remain in his bones when he returns to Earth after 6 months. So in this case, I'm going to go back and deal with the paper, because as I always say, that you possess the intelligence. So you have to solve the problem first before you can involve MATLAB. So let me start with this situation, right? So for example, say you have, or let me first start with a question. I'm going to give this number, right? I start with 100 grams, and I lose 10% every year. At the end of the first year, what is my weight? Oh, sorry, let's call it like 100 pounds. I weigh 100 pounds, and I lose 10% weight every year. So after 1 year, what is my weight? There's a question for you guys. 90. Yeah, no question mark. You should not put a question mark, because if you put a question mark, that means you're not sure. All right, let me ask then the second question, which is a little bit more critical. What is my weight after the second year? Close, but not correct. Why? Oh, yes, but I need an answer from you. Why do you think I need a little, some correction to your answer? What is that correction? Not 63, because we said 10%, remember? 10%. First year, you went down to 90. What, like 30%? No, I'm talking about 10% only, 10%. It's easier with 10%. 81. And the reason is that you lose 10% of the current weight, which is 90. So 10% of 90 is 9, and 90 minus 9, that's 81. So you lose, you don't lose, because otherwise, imagine if that was true. Like if I give you half of what I have, let's say I have a pizza pie, I give you a half. Then from the half that I keep, I give a half to somebody else. So I keep a quarter. And then I give a half of that to somebody else. Now I keep 1/8. If I go 1/2, 1/2, 1/2, 1/2, theoretically, I can go all the way to infinity, and I still have something. So the same thing with weight, because if the answer was 80, that means after 10 years, I disappear. I am 0 pound, right? So the idea of the 10% is the 10% of the current weight on over a year. That's what you lose, right? So that's why you go from 100 to 90, that's 10%. Then from 90 to 81, that's 10% of 90. Then from 81 to 70, whatever, that means you have to subtract 8.1, right? That's 10% of 81, and so on. Then you can keep going like that forever. So now let's go back to the paper and say, imagine that I started with a mass M0 of bone mass, right? Bone mass. And again, I want to remind you that to get a unique answer from everybody, even though in audio they say 1 to 2%, I want everybody to use 1.5%. That's between 1 and 2, right? So everybody use that one. Not 1, not 1.2, not 2, 1.5. Everybody use that one. And of course, 1.5%, that means 0.015, right? That's the same thing, right? The same thing. So, or that's the same thing as 1.5 divided by 100. So that's when you deal with MATLAB, you better remember what percent means, right? So that means after 1 month, you lose, and let's say call this one R, small r. You lose R times M0. That's what you lose. And so what do you keep after 1 month? What is your bone mass? Somebody tells me. This is what I start with. This is what I lose after a month. What is it that I keep after a month? So lose after 1 month. So what do I keep after 1 month? Come on, guys. I'm not asking you a very hard question here. No, that's what you... oh. No, it's not 1.5. Remember, R is 0.015, right? All right, let me give you this question. You have $100 and you lost $2. How much do you keep? So what kind of operation did you do to get it? Yes. Yes, so that means I subtract M0 minus M0 times R. Because this is what I had, this is what I lose, and that's what I keep. Yes. So but I prefer to use R so that in case some other day the rate of loss is different or whatever, then you just plug in the new number, right? So I can then keep it this way. I can factor M0, right? Do you agree? Anything that bothers you so far? Ask away. You don't want to wait, because otherwise, you will not get what I did say after, and then it would be a disaster. You got it? Okay, so now let's redo the whole thing after 2 months, after 3 months, and so on, right? Because they want to know after 6 months, right? So this is what you start with after 1 month, right? Because that's what you keep, that's what you start with, right? After 1 month, lose after second month. I started with M0, 1 minus R, and you multiply this by R, that's what you lose. That's what I started with after 1 month. This is what I lose. And what do I keep after the second month? Again, I'm waiting for an answer. What do I keep? What? Come on, it's a simple answer. I have 98. The dense, yes, without the question mark, David. Don't ever make believe you have doubts when you talk to people. Even if you're incorrect, it doesn't matter. And so the difference is, this is what I started with after 1 month. This is what I lost. And therefore the difference is what I keep. But then I play with it and I say, hey, that's a common factor. So I'm going to factor that times 1 minus R. This looks like M0, 1 minus R squared. When you see this happening after 2 months, after 3 months, without calculations, can you tell me what I will keep? Yes. The only thing that changes, look at this. I mean, here after 1 month, here after 2 months, it's just the power of this thing that changes, right? Everything else remains the same. So that means, of course, I should verify it, but I know that it is true. And therefore, after 6 months, what would be the final result? What do I keep? Yes. And this is what you have to program. Now, a lot of people, no matter what I present, like right now, this is, I show you exactly what you have to program, right? Which theoretically you should have come up with on your own. But a lot of people, even though I provide this information, they still use this one. And that is incorrect. Because, as I said before, if this were correct all the time, then if R, let's say, is 0.1, 10%, and if I say after 10 months, 10 times 0.1 is 1, 1 minus 1 is 0, then you end up with 0 bone mass. And I said, no, it's always some percentage of what you have left. You'll always be left with something. However, when is this approximately equal to this? Is when R is very small. When R is a very, very small number, like in this case 0.015, these two are almost equal. But I still would take points off for this one because this is not the general expression unless you can prove that this is true. Right? Because if I said, if I want to create trouble and I say R is 10%, and after 10 months, somebody's going to say that it's equal to 0, right? Because 10 times 0.1 is 0. Whereas this one, 1 minus 0.1, which is 0.9 to the power 10, that's not 0. It's a small number, but it's not 0. So that would be incorrect because there R is not exactly a very, very small number. So be careful that you don't use this. Right? I would be very disappointed if you do. And you do that for women and men, right? The only difference between the two is that a man starts with 1,500 grams and a woman starts with 1,200 grams. That's all, right? But it's the same calculation. You know, of course, you still have to have sentences and units. Now, the last question here, which is going to be the hardest one, right? And I'm going to go back to the graph. Where are you? Oh, yes. It says that, say an astronaut goes into space with so many grams, m grams of bone mass, and then you want them to come back home, and they have to have the same bone mass, the same. How is it possible? Right? The same amount of calcium as they did after returning to Earth. We said that, you know, astronauts lose a lot of bone mass in space. So how is it that you go to space, then you come back and you have the same bone mass? You haven't lost any. Space crabs. When you're a child, kind of, yes. Explain to me why, when you're a child, it's possible. That's right. The only way for you, it's like, you know, when you go in with $1,000 in your pocket and you're losing 10% every month, how can you come back with the same amount of money? That means you have to be in a situation where during that time, even though you lose, you also gain. But then what do you have to prove, Mr. David? To return with the same bone mass, what do you have to prove? Exactly. You have to lose as much as you gain. And so the point here is to figure out at the beginning, so maybe not as a child, but at least as a young person, if this rate of increase, let's say around 15 and 20 years old, if the rate of increase is the same as the amount of bone mass that you lose because you're in space, then the answer is positive for that question. And so you cannot just answer yes or no. You have to prove that this rate of increase, even though it's given in years, right? But you have to turn it into months, right? You have to turn it into months and see how much bone mass is increasing in this range. If the increase matches the 1.5% that we discussed before, then yeah, it's true. You gain, and then you come back and you have the same bone mass, because what you lose is exactly what you gain, right? Is what you gain. You think it makes sense? You gain and you lose at the same time. So you have to gain as much as you lose. So not only you have to decide, you have to gain as you lose. That means you cannot go when you're a 40-year-old, right? Because there you only lose, you don't gain. So there's no way you can come back with the same bone mass. So it's only at the beginning, right? When you're 20 years or younger, right? But then you have to show that that rate of increase matches the bone mass loss in space. Agreed? Agreed. So that is the second one, right? The second one. Now the third one is not that much of a problem. Okay. Where is it? Where are you? No. Oh, it's here. Sky is falling. Sky is falling. So here, this here is about what happens to gases in space due to temperature. The gases, they can increase in volume, they can decrease in volume, the pressure may be different, the density. So in this case, the density is different, changes, right? So instead of talking about volume, we talk about density, right? So before we talk about the density of the gas, we talk about this thing here called the scale height, H. Oh, sorry, I'm not showing that, so I'm still showing the camera. So in the case of the density of gas in space, due to variation in temperature, and the temperature varies tremendously in space because of the sun, right? It's not like Earth, we have those layers that protect the Earth from such a major variation in temperature, right? So, and you will see that the temperatures that will be considered in space are from a low 700 degrees Kelvin to all the way to 1600 degrees Kelvin, right? And so we would like to know what happens to the density of the gases in space. So in this case, first we look at this parameter called the scale height, which is just kT over mg. Now K is the Boltzmann constant, T is the temperature in Kelvin. M is the mass of the gas, of the atoms that make up the gas, and G is gravity, right? Whatever gravity is, right? Then, so the first question, so it's about just the scale height, right? So in this case, for example, they tell you exactly what you have to use for K, for G, for M, for the temperature, and so on. So it's just a matter of calculations, right? And you're supposed to evaluate that for two different cases, where T is about 700 degrees Kelvin and 1600 degrees Kelvin. So they give you the mass, they give you G, and they give you the Boltzmann constant. You just plug them in and plug in the temperature 700, plug in the temperature 1600, and you've got the answer to the two questions. And don't forget, of course, sentences and the units, right? You have to have the proper units for this height, right? Of course, they say, here it says in meters, but that means if you forgot to mention it in the sentence, you'll be in trouble. Now, they look at what happens to the density of the gases. And this is showing you how the density evolves with the height. Z is the height, right? From Earth, right? The height from Earth. It says that the density at height Z is equal to the density at height 0, that means on the planet's surface, times the exponential or negative, right? The negative may not be very clear, but it's there, right? Negative Z over H. So the exponent increases with the height, decreases with the scale height, but it's a negative number, right? So in terms of magnitude, right? In terms of magnitude, if it gets larger, this becomes closer to 0, right? Exponential of minus 1,000 is a very small number, right? Because it's like same thing as 1 over exponential 1,000. An idea of how it behaves or affects the density, the scale height affects the density, initial value being at the surface of the planet. So again, in this case, I'm going to do some calculations because they will tell you, I know the density at a given temperature, at a given height, and I would like to know what happens to the density when the temperature changes. So not the height is still the same height. Say we have a satellite in that area or some rocket or whatever. We would like to know what happens to the density of the gas around that device when the temperature changes. So it's the same height, right? So in this case, so again, I'm going to start with, let's say that T1 is 700 degrees Kelvin and T2 is 1600 degrees Kelvin. And as you see here, I'm trying to help you in a process where even though I should let you sink or swim, because this is reminding you that if you do not have the intelligence, MATLAB is useless. That means I need to solve the problem before I can program the solution. So in this case, that means the density at temperature T1 would be D0 exponential minus T1 over H1. Because even H changes with temperature, remember, right? H is KT over mg. So everything remains constant, but T changes, so H is proportional to T. Then D2 at different temperature, that's D0 exponential minus T2 over H2. And I know, for example, because they give you the density at 1600 degrees, which is this one. They give you T2, that's 1600. H2 you have evaluated in the previous part. So you find D0, then you plug it in here with T1 and H1 that is known, and you find D1. But I say, look at how, if you made the mistake in evaluating D0, that's going to be a mistake in evaluating D1. So why don't we do this? D1 over D2 equal, obviously these will cancel, right? When they appear, well, I'll just write it down. See here, D0 and D0, they will cancel. And this would be, therefore, now, what is exponential A over exponential B? Can somebody tell me what is exponential A minus over exponential B equal to? Come on, guys. I suppose that's pre-calc, right? Is it algebra or pre-calc? Something. Who knows? Exponential A over exponential B. What is it equal to? If you don't know, just say we don't know. Yes, exponential A minus B. Well, A is in the numerator, so it should be A minus B, not B minus A, right? So that would be, therefore, exponential minus T1 over H1 minus the exponent here. So minus minus, that becomes a plus, and so that becomes plus T2 over H2. And so in this case, what am I saying, T2? Do you remember what the expression was? This is supposed to be Z, the altitude. So in this case is Z, and the altitude does not change, so Z, and therefore Z and Z again. Which I can then, if I want to, not that you have to, I can just put minus Z times 1 over H2 minus 1 over H1. I just factor Z, right? And that's D1 over D2. And so D1 equal D2 exponential minus Z 1 over H2 minus 1 over H1. And that's it. And I hope for your sake you remember all this stuff, because you either want to get 10 out of 10 for this part, or you want to go and get 4 or 5 out of 10 because you're not following, right? Or you ignore all this and do your own thing. And of course, sentences, units, they're very important to the presentation. So, and don't forget that every one of them should include MATLAB program, published work, and with sentences and units. And whenever paragraphs are required, then you better have them. You can type them in through MATLAB, or you can type them in through Microsoft Word. I don't care, right? So it's your choice. So I'm going to limit myself to the first 3 parts for the time being, just to give you an idea of what to expect, and then it's up to you, right? What to start with, when. Like this one, you could just do it today, for that matter, right? You already have enough knowledge to handle this. The one from the previous one, same thing, right? Project part 2. Project part 1, if you deal with bar graph and the pie chart and stuff like that, then you have to be careful, because either if you know what you're doing, you can also start with it. But if you don't know, then you have to wait until we deal with top 5 before you can have access to that information. And there are a few others, that would be also similar in terms of complexities, right? It's very simple. There's one part that is going to be fun, and that part is about music. You're going to create music through MATLAB. Amazing, isn't it? I mean, it's just plain notes, but we put notes together, and that's music, right? So, in fact, just to give you an idea, let's see here. Just to give you an idea. I wonder if this one is the good one. Well, let's see what this does. All right, so let's play it and see what happens, right? Right? Interesting, isn't it? Yes. So now I want to let students know, when it comes to the music file, I'm not interested in you copying somebody else's file and playing it. I'm not interested in you being a musician, though sometimes, some semesters, I have students who are musicians and they know what they're doing, so they know which notes to use when and how long and stuff like that. So I'm not interested in you providing me with a piece of music that is fantastic. In fact, if you're not a musician and you give me something fantastic, you're going to get at best 5 out of 10, right? At best, if not less. And the reason is that I am not condoning plagiarism, copying other people's work. It's about you doing your work. And if you show me that you tried, you may get an 8 out of 10, even if it's not beautiful. Right? But if you copy somebody else's and I know you're not in music, then I know you haven't done any work at all. So same thing with the paragraphs, right? If you write, paragraphs with excellent academic English, and I know you don't speak that way usually, then I say you copied it from somewhere. That's unacceptable. So I prefer your own sentences, even if they have errors in them, than the sentences of somebody else, because it sounds better. Because then you get fired for that kind of situation. At school you don't get fired, but at work you get fired. So be careful. Average work, but your own is 10 times better. Not even 10 times better. I mean, it's 100,000 times better than somebody else's work for which you take credit. Any comments, questions before we go to the lecture? And again, I'm giving you a chance also to ask questions before the exam next week. That means whatever I did before is valid, is part of the exam. That means chapter 1 and 2 for sure. Not what I'm covering today. That will not be part of the exam. So, but this is your chance. If you have any gaps, if you have any questions, this is your chance to ask. The reviews that I conduct are reviews based on your question, not about proposing a problem and you think I'm gonna give you something similar. Of course, I'm gonna give you hints later about what to expect. Yeah, the project your friend says is called NASA project, right? Yes, go ahead, Christian. Ask away. Why is it that you cannot download MATLAB? Your computer cannot handle it, or what? And then you say PDF. Is that the same problem you would have as a doc file?
No.
Document file, that means Microsoft Word?
No.
Then you submit a document file, not PDF. I said PDF or document, right? Second, I need to see an example of a program where you have these parentheses problems, right? Because if you have a problem, it cannot be published. It has to be without errors. So can you share your screen with us, Christian? I'm making you a presenter. Okay, go ahead. As it's not about the online, obviously, it's about the errors. And when you have errors, it will not be published for sure, because it will only list the error that you have. Almost looks like a counter for a download or something, or an app or whatever. Does he have a wireless problem connection? And if you cannot, in the worst case, can you copy and paste it in the chat? Uh-oh, almost there, maybe. Maybe not. Aha! Maybe you have a wireless connection because you're connecting through Blackboard here, and you're trying to connect online at the same time, and your bandwidth is not that high to do both. That's why I said you go to the folder where homework 4 is, and you just open it with Notepad. You don't have to open it with MATLAB. Open it with Notepad. Can you do that? Because here it's going to try to open it with MATLAB, and your MATLAB is online, and online with the conference call here. Obviously, they don't work very well together. You don't have enough bandwidth. So in the meantime, can you go to the folder where homework 4 is, right-click on it, and try to open it with Notepad instead? Of course, in the meantime, maybe you're stuck and you can't do anything else, right? Now just exit. Yeah. Close it. Hey. In the meantime, can you go to the folder where the homework 4 is? Can you do that? The MATLAB folder, or whatever. I don't know where you have kept it, but somewhere. So show us the folder where it is. Alexandro is hungry. And you're not supposed to double click on it, because then it will try to open it through MATLAB again. I said right click. Or just show us the folder, and then I'll let you know what to do. So just share your folder where that homework is. First open it, but don't open the file. Just open the folder, and then I'll let you know what to do. Then right click on it and then open with. Not open, but open with, because open it will use MATLAB. Open with, and you choose Notepad as a selection. Yo, Christian, where are you? See, this is another problem where I need people to have microphones so I can communicate in real time, right? It seems that your microphone is very low volume or something, or because I can't hear you very well. It's moving, but really I think your volume for the microphone is probably at its lowest. Somehow you have to go to the microphone and increase the volume, or test it, test it and then increase the volume to the point where you can hear yourself, and then it's at the right level. But also your bandwidth has gone down, That's why I said don't try to double click on that homework 4. Just share the screen. Not okay. All right. So where did you get? Well, first of all, I remember I don't like when people give me all problems in a single sheet. I want every problem to have its own presentation, right? When you publish the file, you publish one program at a time. Then later, combine the documents together. Combine the documents. But when you run them, I don't want to see problem 1, problem 2, problem 3, problem 4, a list of all these things, because when I want to look at one problem, I want it to be by itself. So where does it say that there is a parenthesis problem? Is that in problem 20? Obviously, I can't hear you, Christian, so you may have to, unfortunately, chat or something. Yeah, we haven't moved yet, Alexandro. So what does Christian say? Which part has given you trouble? I can go line by line, but I'm trying to figure out which line give you trouble. Let's see here, radius times length. Yeah, but L equal length. How can you solve this problem if R and L don't have a number? How can you solve this problem? How can you evaluate this or this? First of all, there is nothing to evaluate about the area. Didn't I say in class that you should not copy the derivations that I provided? That means in class I had to show you how to obtain the cost as a function of one variable only, which is the last line, right? That's it. Everything else was not supposed to be there. Then second, L is not known. If it were known, then you don't have to find it. Or even if you, well, in this case, you didn't have to find it maybe, or you did. But the problem is that it's not known. By saying L is equal to length, you're saying that to yourself. But to MATLAB, it says R equal radius. But our radius is not a number. So it's going to say, what am I going to do with that? Nothing. And it stops right there. You see here, for example, you say V equal 500. That makes sense. That's you giving a value to V. Then you can use it. But here, how are you going to use R and L when R and L are just words, variable names? They're not numbers. Right? I mean, if you want to say, oh, I just want to put that R is the radius, L is length, then put it as a comment. Put a percent in front of it. But then, how do you, did you ever go through the recording? I have the solution on the recording. How can you write your own program that doesn't work when the solution is given in full detail in the recording? Right, Christian? That means you're not looking at the recording at all. I can understand if you say, well, I got it, I don't need to look at it again. But if you didn't get it, then you have to look at it. Right? Exactly. So first, go to the recording. You don't have much time today to do it, right? And it's supposed to be handed in tonight, I think, right? But the recording, I have exactly, the only thing that was missing, maybe one problem, I ignored it because I said, okay, that was on your own. I have to at least grade you one problem for which I didn't provide much information. But the other two, I have solved them completely. The only thing that was missing was sentences, which of course you do not have here either, right? I have to grade you on something, right? And that's on sentences, but the programs are already there in details. You agree with Christian? So I suppose you're going to have to go to the programming thing, the recording, and fix it. And you should be able to do it. If you have no problem, it should publish easily, and you should be able to make it. And that's another problem here, right? You have all these problems, problem 21, problem 35, whatever, and it will not even get to them. It will not even look if they work or not, because the first one is already giving you trouble. And that's another problem when you have them all together at the same time. If you had them separately, then maybe you can execute the second one, you can execute the third one, and you find out they work, and only one would give you trouble. All right, so you get maybe 8 out of 10 or something. But in this case, you're going to get 0 out of 10, or 2 out of 10, or 3 out of 10, because you cannot even execute the other programs to show me they work. In addition to the fact that you don't have sentences or units, and I guarantee you that you lose at least 1 point out of 3 for each problem without sentences. At least 1 out of 3, at least, minimum. Are you going to heed my warning, Christian? Say yes so I can move on. No, heed, that means take into account, respect my warning. So, Alexandro, better make sure you say yes. Unless, of course, you're talking to somebody else, then it's a different story. Yes. Okay. Yes, Christian says yes. All right. And Alexandro better say yes, right? So, got it, Christian? You should be able to do it, right? Hopefully, you're definitely missing sentences, so I would be unhappy with that presentation because you get 2 out of 3 at best, even if they work, right? At best. if not worse, right? And but in this case, if you don't execute all the programs, I would not know if the other two work, because the first one stops it. And that's why I tell the students, write them separately, write them in different programs, execute one program at a time, then combine them as a document, right? Otherwise, if the first one has a problem, the other two will not even be executed, and you get 1 out of 3 for each one at best, right? At least for copying it down. But that's too bad that you would do so many points for nothing, right? So not only should you have them executed, published, and I need sentences and units. Yeah, but I'm saying that look at the recording, and that gives you an idea, right? And you can just copy and paste in different script file and at least show that each one of the other two should work. But then again, if you don't have, like in this case, you don't have sentences for sure, you only have numbers, then you lose 1 point out of 3 for each problem when there are no sentences, at least 1 out of 3. And that is even if they work, right? Okay, so any other questions that could affect the exam? Anything that you want to ask that would be of interest? No? All right. So let's take a break and come back, and we deal with topic 3.